Hello. Yesterday in our class, we have learned a few shortcut formulas for permutations and combinations and how to use them in solving the problems. So today also we are going to learn some more, and after that we will go for multiple choice questions also. Okay, the first formula which we are going to learn today is, suppose there are n things, out of which a few things like P are identical. P things are identical. So let me write that. I'll write P things are identical. Now you have to select R things. In such situation, if you select R things, the number of ways this can be done. For that, there is a shortcut formula, but there are two shortcut formulas. One is, it will start from n minus p cr, then n minus p cr minus 1, and so on. It will go to n minus p c0. But this formula can be used only if r is less than or equal to p. Whereas the other formula is n minus p cr plus n minus p cr minus 1, and so on. It goes up to n minus p cr minus p. This will happen if r is greater than p. There are two formulas. Okay. When we come to examples dealing with this formula, for example, total you have 9 balls, out of which a few balls, that means 3 balls, are same color. And then in this story, you are selecting 4 balls. Selecting 4 balls. So if you see carefully, here R is 4 and P is 3. So if you compare, R is greater than P. That means you have to use the second formula. So the number of ways this selection can be done starts with n minus p. So n is 9. 9 minus 3, n minus p, c, r. Plus, of course, this will be 6c4. Then next, n minus p will be same throughout. Here, 1 less, 3. So here you will have 6c3. Then, until where you will do, the final one should be n minus p, c, r minus p, 4 minus 3. That means the last one should be 6c1. So you can write one more, n minus p, c2 also can be added. So 6c2, 6c4, 6c3, 6c2, 6c1 until this. Okay, 6c4. Start with 6. Instead of taking 6c4, we can also go for 6c2. Start with 6, take 2 numbers by 2 factorial. So this will be 15. 6c3, start with 6, take 3 numbers by 3 factorial. So this will be 20. 6c2 is again what you got in the first term. 6c2 is 15. And we know 6c1 is 6. So when you add 15 plus 20 plus 15 plus 6, Total 56 ways this work can be done. Okay, coming to the next shortcut formula that we will do in the next page. That is the second one. Suppose there is a number n. Again, this n is a number, you will prime factorize it. So after prime factorization, n can be written as p1 power k1 and into p2 power k2 into p3 power k3 and so on pr power kr. Yesterday itself I told you what are these p1, p2, p3. They are prime numbers when you take prime factorization. And k1 is how many times the prime number p1 comes. K2 is how many times the prime number p2 is there, and so on. So now we are going to find total number of divisors of this number n. But the condition is we are excluding either 1 or the number itself, not both. Sometimes you will exclude, you won't count 1. Sometimes you won't count n. Then the number of divisors will be to the power k1 you add 1 into k2 plus 1 so on into kr plus 1, but you will be subtracting only 1. Either this 1 you will subtract, this number 1, or you will subtract the number n itself. For this, again I will give you the example which we have taken in yesterday's class. I will give you a number 38,808. So first we have to do the prime factorization. Yesterday we did prime factorization, but you forgot and even I forgot. So we will do it again. 2 19s, 2 4s, 0, 2 4s. 2 9s, 18, 1. 2 7s, 14, 0 and 2. Then 2 4s, 8, 1. 2 8, 16, 1. 2 5s and then 1. Next 3 16s, 3 1s, 3 7s. Then 3 5s, 15, 1. 3 3s, 9, 3 9s. Then 7 7s, 49. Again 7 7s. So 7 11. That means I can write this as 2 cube into 3 square into 7 square into 11. So suppose if I am finding total number of divisors of this particular number 38,801, but condition is don't count, exclude this number itself. That's the condition. So what you will do, the power 3 plus 1 into power 2 plus 1 into power 2 plus 1. 11 is having power 1, so 1 plus 1. From this you will be subtracting only 1. So here you will have 4 into 3 12 into 3 36 into 2 72 minus 1. So 71 divisors are there for this particular number, but among these divisors you are not counting 38,808. Let us go to the third formula. Suppose again if you take number n and then you will go for prime factorization. And suppose the number n will be P1 power K1 into P2 power K2 into P3 power K3, so on, PR power KR. P1, P2, P3 are prime numbers as usual. Suppose you are going to find all the possible divisors of this number n, and you are finding sum of all these divisors. Then for that also there is a formula, and that formula is, you will start taking the prime number P1 starting from power 0. Then P1 you will take, you will slightly increase the power of P1, that is 1. You will increase the power of P1 again, 2. You will increase the power of P1 again. This you will go until you will get P1 power K1. Now to this you will add P2s. Start P2 power 0, P2 power 1, P2 power 2 until you take P2 power K2. And so on you will do until PR. Start PR power 0, PR power 1, PR power 2 until you go PR power KR. So you will understand better if you take example. I will take the same number 38,808 and I will write the prime factorization: 2 cube, 3 square, 7 square, 11. Now if I want to find sum of all the divisors of this number 38,808, so what I will do? First prime number 2. I'll start with 2 power 0, 2 power 1, 2 power 2, 2 power 3. That's it. I'll stop. Then I'll start 3 prime number. 3 power 0, 3 power 1, 3 power 2. I will stop here. Next I will start with 7. 7 power 0, 7 power 1, 7 power 2. I'll stop. Lastly, 11 power 0, 11 power 1. I have to stop here. Now, we will count what will be the total number. 1 plus 2 plus 4 plus 8. Here, 1 plus 3 plus 9. Here, 1 plus 7 plus 49. And here, 1 plus 11. So here, 3 plus 4, 7 plus 8, 15. And then the next is 1 plus 3, 4 plus 9, 13. The next is 8 plus 49, that is 57. And the last is 1 plus 11, that is 12. Okay, so now we have to multiply. We have to multiply all these. To find the sum, we have to multiply. Multiplication in this sense, now I will erase all these. I will write multiplication everywhere. So we will multiply all these. Once we find the sum of divisors, we will get the answer. So on multiplying all these, I will get 1,27,380. So now I hope it is clear that to find the sum of divisors, you have to take all these and finally multiply. Let us go to the next formula. That is the fourth one. Suppose there is a composite number, not a prime number, but we are taking a composite number n. So if you want to resolve it as product of factors, number of ways you can factorize. I won't write you and all. So number of ways n can be factorized. If you want to find, can be result will be only two factors. Remember, I'm saying factorized, but only two factors. You have to take the composite number n and factorize. But here factorization means I'm giving you formula for only two factors. You are factorizing n such that it has only two factors. And that formula is again, you will take 1/2, 1 by 2 into K1 plus 1 into K2 plus 1 into so on, whatever Kr plus 1 is there. But remember, what are these K1, K2s as I told you? P1 power K1 into P2 power K2 into P3 power K3 after prime factorization. What all you are getting, that is common for all the shortcut formulas. But one thing you have to remember before applying this shortcut formula. This particular formula, remember, n is not a perfect square. Then only you can use this formula. I will box it. Then what will happen if n is perfect square? Will there be another formula? Yes, there is another formula if n is perfect square. That is half into K1 plus 1 into K2 plus 1 into like that Kr plus 1. After that plus. So these are the two formulas. How will you see? How will you see this in the problem? Suppose I'll give you the same number 38,808. The prime factors, or if you want, you can go to another one number also. Not only the same, only thing is we will be wasting some time for factorization. That is why I'm taking the same number always. Suppose if I give you another number 10,800. Now I'm giving you another number 10,800. So first what I have to do, I have to prime factorize it. That is why I gave the same number. So first you will take 5, or you can start with 2 also. The first prime number is 2. So you can start with 2 also. 2 5s, 2 4s, zeros. Then 2 27s, 0 0. Next 3 9s, 0 0. 3 3s, 0 0. 3 100s. Then again you can take 2. So 2 5s, 0. 2 25s, 5 5s. So when you do prime factorization, you will have 2 power 4, 3q into 5 square. Obviously, I can say this is not a perfect square. Why it is not a perfect square? I'll tell you. 4 is even power. 2 is also even power. But 3 is odd power. That is why it is not a perfect square. And so, now if you want to know how to use the formula. So what I will say, number of ways of, I wrote 2 times. Number of ways to resolve n into 2 factors. Which formula I will use? The first formula. 1 by 2 into the power 4 plus 1 into the power 3 plus 1 into the power 2 plus 1. That is 1 by 2 into 5 into 4 into 3. So 2 2's will cancel. 30 possible ways are there. Now, if I give you another example dealing with the same formula, but suppose if I give you a number 900. If I want to write it as perfect square, I'll start from here. These are the prime factorization for 900. So I will have 2 square, 3 square, 5 square. And this is a perfect square, this number. Because here the power is even. For this, the power is even. For this, the power is even. Everywhere we have even powers, no odd powers. So it's a perfect square. Which formula you will use? Second formula. So what I will say? Number of ways to resolve n into 2 factors. What will be the number of ways? Using the second formula, it will be 1 by 2 into the power 2 plus 1 into again one more 2 plus 1, again one more 2 power plus 1, lastly 1 add. You have to add. So you will have 1 by 2 into 3 into 3 into 3, 27 plus 1, 28. So 14 such ways are there. So the concept, you have to see, practice many problems. Then only you will be comfortable with these shortcut methods. These shortcut methods are difficult if you won't practice. These shortcut methods are easy if you practice. Okay, question number 5. Now I will give you n a composite number again. Not a prime number, but you have to take it as composite number. Now, this number n can be factorized, prime factorized again, p1 power k1 into p2 power k2 into pr power kr. Always the same thing, so I'm not explaining again and again. Now, you will find the number of ways it can be resolved. N can be resolved into 2 factors. Same. Resolved into 2 factors. But what is the difference? These factors which are prime to each other. The important condition I'm adding is these factors are prime to each other. So how many ways? For that, the formula is 2 power n minus 1. What is this n? The number of different factors in n. This is represented by small n. Now I know you did not understand anything about this, but I will give you one example, then you will understand. I'll give you a number 18,900. First I will prime factorize it. I will take 3. 3 6, 3 3's, 0 0. 3 2's, 1's, 0 0. 3 7's, 0 0. 7 1's, 0 0. 2 5's, 0. 2 50's, 2 25's, 5 5's. So if you see the factors for this, it is 2 square into 3 cube into 5 square into 7 power 1. Now, what I said is, what are the prime factors mainly here? 2, 3, 5, 7. These 2, 3, 5, 7 are primes to each other. They are called co-primes. So the number of such co-primes we have is 4. N is 4. That means now if you want to write number of ways, n can be resolved into 2 factors. But addition, these factors are co-primes. The factors which we do, they are co-primes. Then the number of ways they can be resolved is 2 power n. I have to take 2 power n minus 1. That is 2 cube. That is 8 will be the answer. Now I think it is clear when to use this shortcut formula. Practice more. Okay, next sixth question or sixth formula. Suppose I have n different things and I have to arrange these n different things into n different groups or r different groups. First I will take r. If I want to arrange it into r different groups, then how can I do that? There are 2 cases. One is blank group is accepted, empty group is accepted, one case. And the other case is there should not be empty group at all. That is the condition. So if there are n different things and you are arranging into r different groups, some groups can be empty, that's okay. First case. No group should be empty, that is the second case. For each case we have different formulas. For the first case, n plus r minus 1 pn. Whereas for the second case, n factorial into n minus 1 c r minus 1. Again, as I said, if you take example, you will understand better. So what I will take in this example is, suppose if I have 5 different colored balls or different looking balls, whatever it is. 5 different balls are there and you have to arrange them in 3 different boxes. 3 different boxes. But the condition is no box should be empty. No box is empty. That is the condition. That means empty group is not accepted. So the number of ways will be n factorial, that is 5 factorial, n minus 1, c, r minus 1. 5 factorial is 120, 4c2. 4c2 is, start with 4, take 2 numbers, divide by 2 factorial. So 720 ways it is possible. Let's go to 7th shortcut formula. Again here I will take n different things. This time it is not arranged, it is distributed to r different groups. That is the difference between the previous formula. Arranged distributed, two different words. So here the formula will be r power n minus rc1 into r minus 1 power n plus rc2 into r minus 2 power n, so on, minus 1 power r minus 1 into rc r minus 1. But here there are no two cases. When you are distributing into groups, blank groups are not allowed. No question of blank group. No blank groups. No empty groups. I can write blank or empty. So no empty groups. That is the condition. So only one and one condition is there here. There are no two different cases. Okay, taking one example into this, we have 5 different balls. And these balls are distributed to 3 persons. This times not 3 boxes. It is distributed to 3 persons. So that every person will get the ball. Every person gets ball. That means no person's hand should be empty. No empty group. That is what they are saying. So what you will do? The number of ways. How will you write the formula which I gave you? R power n 3 power 5 minus RC1 3C1 R minus 1 3 minus 1, that is 2 power 5 plus RC2 R minus 2 3 minus 2 1 power 5. After that it is of no use. It will become 0. Isn't it? So you have to stop here. You can't go more than that. Even if you take the next term, RC3, 3C3, then R minus 3, 3 minus 3, 0 power 5. That's why I'm not taking this term. Okay, 3 power 5 is 243, 3C1 is 3, 2 power 5 is 32, 3C2, start with, actually 3C2 can be taken as 3C1. And 3C1 is 3 only into 1. So you have 243 minus 96 plus 3, or the answer is 150 ways. So coming to 8th shortcut formula of today. Again we will take n different things. These n different things are distributed. Here also distributed. But this time into r different boxes. These are not groups, persons. It is non-living thing into r different boxes. But empty boxes are allowed. You can have empty boxes, no problem. That is the condition. So what will be the number of ways? The number of ways is r power n. Very, very simple. So I'm not giving any example for this. Let us go to next shortcut formula, 9th one. Suppose there are n identical things and you have to distribute to r different groups. Different stories, different cases, different formulas. So if this is done, then how many ways it can be done? Actually, there are two formulas. One is empty group accepted, allowed. The second is empty group not allowed. Two cases are there. When empty group can be counted, the formula will be n plus r minus 1 cr minus 1. When empty group is not to be counted, n minus 1 cr minus 1. Two formulas. For this, I will give you example. Suppose you have 5 identical balls which look exactly alike. You are distributing it into 3 different boxes. Then number of ways you have to. But the condition is no box remains empty. Empty boxes not allowed. So you have to use the second formula, n minus 1 cr minus 1. That is 4c2. Start with 4, take two numbers by 2 factorial. So it can be done in 6 ways. I'll give you another example. Down. Suppose 4 boys picked 30 mangoes. So we know that 30 mangoes look almost identical. If they are mixed up, we can't say which mango is which. So you have to divide these mangoes, you have to divide. In how many ways it can be done? So first thing is the mangoes are identical. Usually mangoes will be identical. So in how many ways you can divide? So here, when you are dividing, if I say empty group is allowed, if I say empty group is allowed, that means one boy will not get mango at all. That is possible. For that, you have to use the formula n plus r minus 1 cr minus 1. 30 plus 4, 34 minus 1, 33 c3. Start with 33, take 3 numbers 32, 31 by 3 factorial, that is 6. So 2 3s, 2 16s, 3 11s. And when you multiply this, you will get 5,546 ways are there. The next 10th formula. These 10th formulas from here, they are really interesting. And they look different also. Suppose you have a square. There is a square of size n by n. One side is n, the other side also n, the third side also n, fourth side is also n. And suppose in this square, you are drawing rectangles. Number of rectangles of any size you are drawing in this square, which I am talking about. So that will be sigma r cube. R is from 1 to n. But instead of number of rectangles, if you want to see number of squares of any size that can be drawn inside the square, that will be sigma r square, r equal to 1 to n. Practically what I mean is, suppose if you have a square like this, and in this you have to draw rectangles. So in how many ways you can draw? Here a rectangle, here a rectangle, here another rectangle, here another rectangle, like that. In how many ways the number of rectangles of any size can be drawn inside this square? That is what is being asked. But with example only you will understand better. I'll show you example also. But let me go to one more formula. There is a rectangle this time, and the rectangle size is n by p. Length is n, width is p. That is why it is a rectangle. And remember, when I'm talking about n and p, n is less than p. This is very, very important information. Then you can draw rectangles, the number of rectangles of any size you can draw inside this rectangle. And that, how many? It is, the formula is np by 4 into n plus 1 into p plus 1. Suppose if you are drawing squares, number of squares also you can find of any size inside this rectangle. There is a formula for that also. But that formula is little bit complicated because it is sigma n plus 1 minus r into p plus 1 minus r, where r will be from 1 to n. As I told you, two formulas. If I give you two examples, you will understand better. So first example, I will take rectangle. The dimensions of the rectangle are 9 by 6. So which is n, which is p? Because n is less than p, n has to be 6 and p has to be 9. Remember that. So that is the rectangle's dimensions. Now you have to find number of rectangles drawn. Number of rectangles of any size inside this rectangle that you have to find. So you will take NP, 6 into 9 by 4 into n plus 1, 6 plus 1 into p plus 1, 9 plus 1. So 2 2s, 2 3s, 2 1s, 2 5s. Is this clear? Okay. So you will get total how many? 945 rectangles. Number of rectangles. But suppose if I give you one more question here itself. Count the number of rectangles of any size in the rectangle which you have to draw, but exclude squares. Remove the squares. So what you will do? First of all, you found the number of rectangles. From this, remove the squares. What is the number of squares? Sigma n plus 1, 6 plus 1 minus r into p plus 1, 9 plus 1 minus r. R is from 1 to 10. Or it will be 945 minus sigma 7 minus r into 10 minus r. R is from 1 to n. N is 6. 1 to 6. So what we are doing here specially, try to understand the question. We know how many rectangles you can draw inside the rectangle. 945. But in these rectangles, you are counting the squares also. So exclude the squares. This will be the number of only rectangles which are not squares. Now, how to add this? There is a different method and a long method. I will do it on the next page. So what you have is 945 minus, I will go back and see, 945 minus sigma r equal to 1 to 6. Sigma r equal to 1 to 6, where we left the last step. 7 minus r, 10 minus r. So 7 minus r and 10 minus r. So I will simplify like this. 945 minus sigma r equal to 1 to 6. I will have 70 minus 17r plus r square. This is what I have. Now how to solve this? 945 minus, take sigma for 70. Minus, take sigma for 17r plus take sigma for r square. For each one, you are taking different sigmas. This is how you will deal with sigmas. These are the rules which I am telling you about sigmas here itself, instead of explaining separately. So now you have 945 minus, take 70 outside the sigma because it's a number. Take 17 outside the sigma and take nothing. R square, it will be inside the sigma. Why I did? Because we have some formulas. I will write those formulas here. Sigma 1 is just R. Sigma R is R into R plus 1 by 2. Sigma R square is R into R plus 1 into 2R plus 1 by 6. Sigma R cube is R square into R plus 1 whole square by 4. So these formulas you can apply. That is why I simplified the problem in this manner. So I have 945 minus 70 into sigma 1 is R itself. What do you mean by R? When I am saying R equal to 1 to 6, that means R is 6. So I will take 6 minus 17 into sigma R formula. R is 6. 6 into 7 by 2. Sigma R square formula. 6 into 6 plus 1 into 2 into 6, 12 plus 1, 13 by 6. Then I will simplify all these. So I will have 945 minus 420 plus, I am multiplying 17 into 3 into 7. So that will be 357. But I have to minus this one. Minus 357. Okay, minus 357. Lastly, I have plus 91. Actually, this 91 also will become minus, because this minus is going here. This minus is going here, so it will become plus. This minus is going here, so it will become minus. That means here 357 is added and then minus 90. Okay, this is correct now. And so you will get 791 ways. Only simplification is little bit difficult. Okay, I will give you another example here, just to make you familiar. Suppose I will give you a square of size 6 by 6. And now if I ask you the number of rectangles of any size in this square, if you have to find. So what is the formula? Sigma r cube. R is from 1 to n. So what I will do, sigma, what is r? R equal to 1 to 6, because n is 6. The number of sides n is 6. Okay, but what is the formula? Sigma r cube formula, I already told you. R square into r plus 1 whole square by 4. So 6 square into 6 plus 1, 7 square by 4. This is what you will take. So 36 into 49 by 4. 4 nines. And so 9 into 49, 441 ways. Same question if I ask you the number of squares of any size inside this square you can draw. The formula here will be sigma r square. R is from 1 to 10. So I will have sigma r square. R is from 1 to 6. So r square formula is r into r plus 1 into 2r, that is 12 plus 1, 13 by 6. 6 and 6 cancels, 91 ways it is possible. Okay, so now I will tell you some more formulas, but for these formulas I won't give you examples. You only take examples and try. Because if I start giving too many examples for each shortcut formula, I can never complete this chapter. So let us take some more important formulas. I'll start with one. Suppose I'm having n number of straight lines in a plane such that no two lines are parallel and no three lines are concurrent. Concurrent means meeting at one point. Concurrent means the three lines are not meeting at one point. This is concurrent. They are not. See that not, very important. They are not meeting. So no three lines are concurrent. So the plane will be divided into parts. How many parts? the number of parts, the plane gets divided. Plane gets, oh, see the spelling of gets. What did I write? The plane gets divided. That I have to find. And the formula for this is 1 plus sigma n. I'm not giving example for this. Next example. If I want to find the sum of digits in unit place of all numbers formed by the digits. What are the digits? Let me write the digits spelling clearly. What are the digits given to you? The digits given are A1, A2 up to AN. All at a time you are taking. So what work is going on actually here? You are given digits. You are taking all the digits at a time and you are forming numbers. Many numbers are formed. After forming the numbers, you are taking digits in unit place of every number and you are adding. So that sum we are supposed to find. So how to find? First, how many digits are there? N digits are given to you. So you take n minus 1 factor. Multiply to it. You add all the digits which are given to you. And then multiply with 10 power n minus 1 by 9. This is the shortcut formula. The formula itself is very big. But if you by heart this formula, if you are good at all the formulas, you can save lot of time in your exam. Okay. The next formula is total n questions are there in exam. Number of ways of answering one or more questions that you can find by taking 2 power n minus 1. That's the formula. Okay, fourth formula. Suppose you have n questions in the exam. Then what you're finding is number of ways of answering these n questions, but answering one or more of the questions given. That condition is there. But remember, the most important condition is each question has alternative. Choice. Choice is given in every question. So that is the important thing to be noticed. And now here number of ways will be not 2 power n minus 1. It will be 3 power n minus 1. Okay, very soon we are going to end these formulas. The next is, suppose you have total n questions. So again you are answering number of ways of answering all questions, leaving nothing. But again, each question has alternative. Each question has choice. In such a way, the formula can be taken as 2 power. Okay. The next shortcut formula is, it is very, very known that n factorial plus 1 is not divisible. Always. Try anywhere. It is not divisible. N factorial plus 1. Okay, let me give you the last formula, the shortcut formula. After that, we will practice lots and lots of problems. Okay, now here we will take one equation. Let that equation be x1 plus x2 so on xr equal to n. Now for this equation, you will have many solutions. So the number of non-negative solutions we are seeing, that will be n plus r minus 1 cr minus 1. But in the same example, if you take number of positive integral solutions, what will it be? N minus r, cr minus 1. Okay, one thing I want to tell you here in this concept. What is non-negative and what is positive? Non-negative means which are not negative. What do you mean by non-negative? Non-negative means not negative. Not negative, what all you will get? Not negative. 0, 1, 2, 3 or. But if I say number of positive, I mean 1, 2, 3 and so on. So very clear concept. Now we can go to the questions. First one. The tens digit. You have to find the tens digit of 1 factorial plus 2 factorial plus 3 factorial so on up to 49 factorial. So first what I will do is I will take 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. I am not going to add up to 49 factorial. So this will be 1 plus 2 plus 6 plus 24. So you got 33. You are taking the number and you got the sum 33. Okay, 33 I will write here separately. After that, I will find 5 factorial. It is 120. I'll find 6 factorial. It is 720. I will find 7 factorial. What is 7 factorial? 5040. I will find 8 factorial. 40,320. And finally, I'll stop. I can't find too many factors. So I'll stop at 9 factorial. It is 3,26,880. So only until here I found. So already 33 is there. Already the sum 33 I got here. So basically what I'm seeing is I'm just adding 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial plus 8 factorial plus 9 factorial I'm adding. So when I add all these numbers, of course I'm not worried about ones because 3 and all zeros. So 3 it will. That means nothing is carried. So without carrying, now 2 plus 2, tens digit. 2 plus 2, 4, plus 4, 8, plus 2, 10, plus 8, 18. And then 1 is carried out. So did you see what are we getting? If I do like this, what will I get? So units place is 3, nothing is carried. Now we will see tens place. In tens place, I can't add 33. What I want to show you is one very, very important thing I want to show you. 1 second. Yes. What I want to tell you is here, this sum which I got 33, I will come to this later. Remember this 33 I have. When I add 1 factorial, 2 factorial, 3 factorial, 4 factorial, I'll have 33. Remember that. Now what I have is 2 plus 2, 4 plus 4, 8 plus 2, 10 plus 8, 18 and then 1 carried. So clearly I have 8 here. Apart from that, I have 33. This 33. So I will be having 1 and 1 carried. Is this clear? So I'm taking only tens digits. I'm taking only tens digit. That is why to this 8 which I got here, to this 8 which of course I have carried. See? Let me show it to you again because it is difficult to understand. Once you understand, it is easy. I am adding only tens digit. 2 plus 2, 4 plus 4, 8 plus 2, 10 plus 8, 18. In tens place, I will keep 8 and I will carry 1 to the other place. So leave that. Leave about that. Ones place also, I don't know what I have. Okay, ones place 0, 0, 0, 0, 0. All zeros are there. Ones place. Next, when you take 33 and add, I will have ones place 3, but tens place 1 and again it is carried. So finally, the tens digit, I am getting 1 here. Tens digit, which they are asking for, I am getting 1 here. Now the question is, why did I add only till 9 factorial? Why I did not go till 49 factorial? What happens is, after 9 factorial, if you start with 10 factorial, it will have 2 zeros in the end. 11 factorial also will have 2 zeros. 12 factorial also will have 2 zeros. Like that, 49 factor also will have 2 zeros. So, the tens contribution is 0 here, tens digit. That is why we can count only up to 9 factorial and you can say that the tens digit is 1. to the next one. Total there are 21 football matches happening. And then when there are matches happening, there are chances to win, there are chances to lose, there are chances to draw. But the question is, if you make prediction, the number of predictions, if you make prediction in the beginning itself, if you make number of predictions and that contains exactly 18 predictions correct. So how many predictions can be made? See the question. There are 21 football matches happening. So these matches can be won, lost or drawn. We are predicting these football matches results. We are predicting. We are guessing. The number of guessings that contain exactly 18 guessings correct, that you have to find. So what we will do, because total 21 football matches are there, total 21 football matches are there, and out of these 21 football matches, what they said, 18 correct results should be there. Correct prediction. Exactly 18 should be there. That means the remaining 3 predictions are wrong. Out of 21, 18 correct predictions, 3 wrong predictions. In how many ways that can happen? That is what they are asking. So, from 21 matches, we can select 18 correct predictions. After that, these wrong predictions, the 3 wrong predictions, all the 3 may be winning, all the 3 may be losing, all the 3 may be drawn. So that means it is repeating. When I say, listen carefully, wrong prediction, there are 3 wrong predictions. This wrong prediction, this wrong prediction, this wrong prediction. Why it became wrong? Because I said win instead of lose. So 2 ways are there for me. When I say wrong prediction, when I got wrong prediction, actually 2 choices were there: winning, losing, or winning, drawing, or losing, drawing. 2 choices are there. Out of that, I will select one. So when I am taking the 2 choices, imagine I am taking winning and losing. 2 ways I can predict when I'm going for wrong prediction. That means the drawing prediction is correct. Match got withdrawn. The second is I can take lose and draw. 2 predictions are possible in this way. Then I will take win and draw. 2 predictions are there. 2 choices are there for me in each way. In 3 wrong predictions, what I did is, instead of win, maybe I told loss. Instead of loss, maybe I have told drawn. Instead of drawn, maybe I have told win. Like that, 2 cases are there. So I have to multiply 2 cube to complete this work. First of all, I'm seeing in how many ways correct prediction can be done. After that, I'm coming to the wrong prediction 3. That is also necessary to complete one work. And then you can leave the answer like this. Because here, simplification is not done, even in the question. I think for today, this is enough. In the next class, we will do more problems. The problems will be difficult. If you understand, they will be easy. Okay, see you then. Next class we will meet.